Students, this is the last segment of lecture 4. There might be some noise and I'm sorry for that. In this segment, we are going to learn about multinomial expansion and we will be focusing specifically on determining the general terms of multinomial expansion. Since multinomial expansion is a vast topic, we will be talking about it briefly, and it has very close relation with binomial theorem, and concepts of binomial theorem is highly used in determining multinomial expansion. So we will see the comparative analysis of multinomial expansion with respect to binomial theorem. At first, as we know, binomial expression has two terms like this. This is a binomial expression. So from the name of multinomial expansion, we know in case of multinomial expression, there must be more than two elements like this, or 2x plus 3y plus u v w whole to the power 100. This is a multinomial expression, but the general form like this of multinomial expression is a1, a2, a3 up to ak whole to the power n. Compare these two. This is the form for binomial expression and this is the general form of multinomial expression. Okay, as we can remember, in fact 0 of binomial theorem, we got that if we expand this expression, we will get many terms, and those terms, each of those terms will have a form like this. Remember, ki a to the power x b to the power r. This is what we got in our fact 0, right? Okay, similar to fact 0 of binomial, in this case we will also get some terms like this, but in this case there must be a coefficient like ki for each of the terms, and we see both of a and b here. So here we will see all of a1, a2, a3, a4 up to ak, right? And we see that a has an exponential, b has an exponential. Similarly, we will get x1, x2, x3, x4, xk, all of this as the exponential. So this is the general form of the terms of the expansion of multinomial expression. Okay, this is the general term for multinomial, and this is the general term for binomial. Okay, then in fact 1 we got that a plus b up to a plus b. How many a plus b's are there? Total n. We got that in each of the terms, like ki a to the power x b to the power r, in each of the terms all of these factors provides only one element per factor. Okay, and similarly in this case as well, if we write a1, a2 up to ak whole to the power n and factorize this, we will get a1, a2, ak into a1, a2, ak, like this. It will go on a1, ak, right? So it was a plus b whole to the power n, and this is the multinomial expression a1, a2 up to ak whole to the power n, right? This is multinomial and this is binomial expression. So in this case, since all of those factors in binomial contributed one element in its general term, all of these n factors will also contribute one element in the general term of multinomial expansion. So each of them, see, We can take a1 from here, a1 from here, then a1. All of them will be multiplied and we will form each of the terms of multinomial expansion. Can we relate? Okay, this was fact 1. In fact 2, we got that in case of a binomial expression, in each of these terms, ki, a, x, br, in each of these terms, what will be their degree? We got that the degree is the sum of the exponents. So the sum of the exponents are x plus r. And what we got there was x plus r equals to n. Can you remember? Yes, because how did we get that? We get that like all of these n factors will provide one element, and each of the element having 1 as its exponent, right? So the sum of the exponents will be 1 plus 1 plus 1 up to how many ones will be there? N. So here we got x plus r equals to n, right? X plus r equals to n in the fact 2. Similarly, here in fact 2, you can say that each of these n factors will provide one element. And how many total elements will be there? N elements will be there, and each of them will provide like a1 or a2 or a3, and all of those single elements exponent will be 1. So the total of the exponents 1 plus 1 plus 1, how many elements? N elements. All of their exponent is 1. So the total or sum of the exponents will be n, since there are n ones. So in this case, x, these are the exponents, right? x1 plus x2 plus x3. In the general term, all of these are exponents, x1, x2, x3 up to xk. All of their sum will be n. Okay. Now, fact 3. It says that the coefficient of a term refers to the total number of times this term appeared, right? It was in fact 3. Coefficient ki. Okay, so if we have to determine the value of ki, we'll have to count how many times a to the power x into b to the power r appears. Okay, similarly in this case as well, fact 3 will be ki x1 up to ak xk. This is the general form, and it is the term. It means that this term here, red marked, this red marked term appeared total ki times in the expansion of that multinomial expression. Okay, so this was our fact 3. Then fact 4, what we get? In fact 4, it was said that ki equals to nc r into n minus r c n minus r. Yes, this is a bit difficult. Can we remember how we got that? We got that since there are x number of a's and r number of b's, right? And where x plus r equals to n. How did we get that? We got that out of total n factors, we will have to choose x number of a's, then x equals to what? X equals to n minus r. That means, okay, out of total n factors, we'll choose r number of b's and x number of a's. In how many ways we can choose r number of b's? N, C, R different ways will be available for choosing b, and there will be remaining n minus r number of terms or factors which will provide a. So among all of those factors, n minus r factors, all of them, n minus r of them will provide a. So NCR, from this we got b to the power r, NCR, sorry, NCN, n minus r, Cn minus r, from this we get a to the power x, right? So this is the total number of ways in which we can get a to the power n minus r into b to the power r, right? So how do we count ki here? This is very simple. We can say that from the general term a1, x1, a2, x2, a3, x3 up to ak, xk. In our selection, how many a1 will be there? X1. Total how many numbers of factors are there? There are total n factors. How many will provide a1? X1 of those factors will provide a1. So n, c, x1, different ways to choose a1. Choose x1 number of a1. Then how many will be remaining? There will be n minus x1 factors remaining. Among all of those factors, we'll have to pick x2 number of a's, right? So among the remaining ones, how many ways can we choose x2 number of a2's? n minus x1 number of options, and will take x2 number of a2's. And then how many will be remaining? N minus x1 will remain. Now n minus x1 minus x2. And among these, all of this, how many a3 will we choose? x3 number of a3, that is n minus x1 minus x2, x3, right? So this is how we will keep on choosing, and at last, when we can remember that from fact 1, x1 plus x2 plus x3 up to xk equals to n, right? So when we will be finished with choosing ak minus 1, then how many of the factors will be remaining? There will be xk number of factors remaining, and at last, among all of those xk, we will pick xk number of a's. So in how many ways we can do that? xk, c, xk. So this is the total number. This looks scary, I know. This is the total number of ways in which we can make a1 x to the power a1, a2 x to the power a2 up to ak x to the power ak. This is the many times which this term will appear, right? Okay, so we want to simplify this term, right? This is really ridiculous, and so we'll have to simplify that. Okay, let's try it. See, we got nc x1 into n minus x1 c x2 into n minus x1 minus x2 c x3 into n minus x1 minus x2 minus x3 c x4, right? It will keep on going, and at last we will see xk c xk. Okay, we can simplify this in a simple manner. For example, according to formula n factorial, n minus x1 factorial into x1 factorial, and at the numerator will get this, and n minus x1 minus x2 factorial into x2 factorial, right? And then here we get n minus x1 minus x2 factorial will get n minus x1 minus x2 minus x3 factorial. For this is r here, right? Factorial into x3 factorial, and it will keep on going like this, and at last we'll get xk factorial divided by xk minus xk, that is 0 factorial, into xk factorial. Okay, Now we can see that here is an n minus x1 factorial. Here it will be cancelled by this. This will be cancelled by this. It will be cancelled by the upper portion, and similarly for the last term, this xk factorial will be cancelled by the denominator of the previous term, right? So what we will be left with is, see, all of the denominators have been cancelled, only n factorial is prevailed, n factorial, and we get x1 factorial, x2 factorial, x3 factorial, and we know how will it go. At last we will get xk factorial. So at last we have determined the ki for the general term of a multinomial expansion, right? Xk. This is the ki, or this is the coefficient. So now what we will be focusing on which is very important what I'm writing now. In multinomial expansion, we'll have to remember these facts, only these two facts basically. Those are, number one, sum of all of the exponents sum is equal to n according to the degree of this multinomial expression. And the second fact is the general term of a multinomial expansion is n factorial, x1 factorial, x2 factorial, x3 factorial up to xk factorial. This is what? This is the coefficient, and the remaining part will be a1 to the power x1 into a2 to the power x2, and it will go like this, and at last ak to the power xk. So this is the general term. Okay, this is the general term of a multinomial expansion. Okay, so now we can solve a problem on the basis of this formula. At first, if I say that in the expansion of a plus, this is a problem, okay, b plus c plus d whole to the power 22. If I say that there is a term which has a coefficient ki, and the remaining part is a to the power 2, b to the power 10, c to the power 8, d to the power n, right? So I said that in the expansion of this we have a term like this. Now may I ask you, from this question, n equals to what? What will be the answer? As we know that from here the sum of the exponents of a general term x1 plus x2 plus x3 is always n in case of multinomial expansion. So in this case, all of these are the exponents. So according to the first theorem, here we get 2 plus 10 plus 8 plus m will be equal to what? N. Here n equals to what? 22. So we get m equals to 22 minus this 20, that is 2. So we can easily get m equals to 2. And now if I ask ki equals to what, how will you answer that? You answer it like, as we know, ki equals to n factorial divided by x1 factorial, x2 factorial, x3 factorial up to xk factorial. So we can easily replace n by n's value was 22, 22 factorial, x1 value is 2, 2 factorial, x2 value is 8, sorry 10 factorial, x3 equals to 3, 8 factorial, and at last what we got is xk, the last term m equals to 2, so 2 factorial. So this is the value of k for that specific term, right? Okay, next question, and this is the last question. Here if I ask you that in the expansion of 2x plus 3y plus z to the power 10. Okay. If I ask that what will be the coefficient of x square y to the power 7 z to the power 1, what will be the coefficient? How will you answer that? You are supposed to determine ki, right? But here we can say that this is our a1, this is our a2, and this is a3, right? According to the formula, the general term will be n factorial x1 factorial x2 factorial x3 factorial, since here there are only 3 options. So x3 factorial into a1 to the power x1, a2 to the power x2 into a3 to the power x3, right? Okay. So here n value is 10, that is 10 factorial. x1, what is the value of x1? So what will be the power of x here? I mean, here we can see that a1 equals to 2x, right? a1 equals to 2x. So we will write here that 2x to the power x1, 3y to the power x2, and we will write z to the power x3. And x1 from here we get that x1 equals to 2, that is it equals to 2, and it will be equals to 7, and x3 will be equals to 1. So here we get 2 factorial, 7 factorial, and 1 factorial. But will it be finished here? No. As we have to determine the coefficient of x square y to the power 7 and into z, here we get something extra, right? 2, 3. So the coefficient will be 10 factorial, 2 factorial, 7 factorial, 1 factorial, and we'll get 2 to the power 2, 3 to the power 7, and 1 to the power 1 here. And at last we will be left with x square y to the power 7 into z. So this total portion is the coefficient of x square y to the power z, y to the power 7 into z. That's all from my multinomial expansion. Hope you understand it well. Try to concentrate on these videos and watch it frequently. As we know, this is a bit difficult topic. Hope you will understand after watching it more and more. Okay.